William, your videographer from Two Hats Publishing. Welcome to the College of Complexes, being held at Barbeck's Restaurant at 8949 Garland Road, Dallas, Texas. Gently embracing the east side of White Rock Lake. When I entered, I was greeted like coming home to Grandma's house, warm and friendly. When visiting the Barbeck's Restaurant, tell them you want your reservations for the next College of Complex class.
Well, welcome to the College of Complexes. This is our 226th meeting since we started, and when was it? February of 2009. Tonight is speaker number 226, so 225 speakers have been here before him. And this actually started in Chicago in 1951 for the purpose of solving all the world's problems. They're still working at it. And we put a speaker on every week, a different subject. We require speakers to take a position on an issue, express a point of view. If anybody interrupts the speaker, remind the interrupter we only listen to one fool at a time. That's one of our rules, and we enforce it. And then we have questions and answers, not speeches. Then we have remarks, rebuttals. Everybody in the audience gets 5 minutes at the podium to respond to what the speaker said, for or against. And the speaker gets a comment on the comment and close the meeting. He gets the last word. That's how it works. Anyway, before we put on our speakers, we have announcements. Are there any announcements? Anybody have any announcements they want to make? Now's the time. Now you should come on up here, Shelley. Shelley Sheridan is going to make an announcement. I don't know what it's going to be, but we'll find out.
Oh, I just wanted to let you guys know that the Women's Chorus of Dallas is going to have a Mother's Day concert on Mother's Day at the Texas Garden, which is over by Fair Park, Texas Discovery Gardens. It's going to be at 2 o'clock. If you want information about the tickets, you can go to the website, twcd.org. And we will be performing there, and there will be a butterfly release in the butterfly garden. All kinds of different stuff. We doing some stuff in Spanish. A lot of it is very mother, women-oriented type of thing. One of our favorites is Music in Our Mother's House, Wind Beneath My Wings, stuff like that. So we do all kinds of different things. So hope you can come.
Any other announcements? Now's the time. Jim, you got your usual announcement? Okay. Yeah. All right, I've got it already, so we're all set there. No announcements to make. I got one, just so you know that we're being taped today, so. What's that? All right. Well, anyway, we should take care of our waitress and take care of the people here. They're good to us, and you got to remember that. So, order something. We don't care what it is. They don't charge us for the room, so that's a good thing. Keeps the cost down. Anyway, next week is what impact will our federal debt have on America's future economy? That's Calvin Bulett. He's a government professor at Clear Valley College. It's on the itinerary I handed out to you. I'm not going to read all this to you and put you to sleep, but he's our speaker next week, and it should be interesting. There's another speaker in July that's listed there, Stop Alec, July 26th. It's way off, but anyway, that's coming up, so don't forget it. Tonight's speaker is Dr. Chris Boldt. He's going to talk about did Albert Einstein affect a lasting legacy? Dr. Chris Boldt is a mathematics professor emeritus. He's going to discuss the legacy of Albert Einstein. How, if you can't explain it simply, you don't understand it well enough. How the simple and unassuming manner of life is best for everyone, best for both the body and mind, unquote. And will argue that Einstein's contribution to America saved more lives in World War II than any other single individual. Dr. Boldt will make a PowerPoint presentation with many photographs and will touch on some mind-boggling consequences of relative theory. So without further ado, Please give a very, very warm welcome to Dr. Chris Boldt. It's all yours, sir.
Thank you very much. I fell in love with Dr. Einstein after sometime in the 80s. And the thing that was so impressive to me about it, I was blessed to have been an officer at the national level of 2 national mathematics organizations and on the panel of visiting lecturers for the 3rd, and I'm talking about the National Council of Teachers of Mathematics, the American Mathematical Association of 2-year colleges, and the Mathematical Association of America. I also served as vice president of the Organization of College and University Math Chairman in Texas. And the reason I bring that up, I've been fortunate enough to work with some very accomplished mathematicians. And what I came to find out, what I think I've learned, is those that were the most productive were more down to earth and humble than some others who were a little uppity, you know. And Einstein is just the perfect example of that. Have a few things I wanted to mention. The first question I'm asking is, do you folks truly know what you're doing? And until I saw what I'm going to show you next, I didn't know what I was doing. But I'm going to tell you now, okay? You're spinning about the Earth's axis at about 1,000 miles an hour. You're orbiting around the sun at 67,500 miles per hour. You, as a part of the Milky Way galaxy, are moving toward the constellation Hydra at about 1.34 million miles per hour. And you are also moving away from the center of the Big Bang at 2.7 million miles per hour. We're flying through space at 2.7 million miles per hour. Now that could make you dizzy, you know. The Milky Way galaxy, of what we're a part, has a diameter of 100,000 light years. That means if you were on one end of it and you shined a spot of light to the other end, it would take the light 100,000 years to get there. Here's a poster I had in my office for years, and when I retired, I brought it home and put it right outside my bedroom door. I love this, and at 74, I'm afraid that I'm enjoying it a little too much. But as he said, I live in that solitude which is painful in youth, but delicious in the years of maturity. And I've developed weird, I work on various little writing projects and everything, and my best time and my energy point of the whole day starts out about 3 or 4 in the morning. It's really weird, but it's totally quiet. Yeah, totally quiet, and I can think pretty fast at that time, and by noon I've slowed down to about 2 miles per hour. The 2 areas are 2 basic reasons that I ended up being familiar with Einstein. In 1976 and 77, that school year, I took a National Science Foundation course for college teachers at the University of Colorado at Boulder, which was entitled Cosmology and Relativity Theory. And being a mathematician, I was very fortunate. One of my best friends from here in Dallas that had a PhD in physics sat beside me, and whenever they touched on something I didn't know about, I'd nudge him, okay, explain it to me. And so I was very fortunate. The second item was in 1980. For 5 years after I got my doctorate, I went over 5 of the next 6 years, I went over for 6 weeks and took a postdoctoral graduate course at the University of Hawaii at Manoa. And each time I'd go over there and take a course, I was primarily interested in their psychometrics, that's psychological statistics at that point. But each time I went over there, I'd work on a project of some kind, and this, in 1980, it's never been published, I've never really tried, but I used it primarily. I made the speaking circuit throughout the nations with some national organizations and some statewide organizations of a talk entitled Geometrical and Functional Insights Concerning the Consequences of Relativity Theory. So I had a lot of fun with that. And so those two items are kind of what got me into that and what got me into dealing with Einstein. And in fact, the other point that was so interesting, I told you how humble Einstein was. He wrote, I had numbers of, when I was working on that writing projects, I had numbers of books. The easiest one to read was his. He brought it all home. And you'll see some philosophy later on that he stated just as much that was what he was doing and that was his goal. So I did some quotation books I used for this, and then his book Ideas and Opinions and Relativity by Einstein, although I had some others too, but those were primarily what I selected for this. I've got another talk like this where I give the proof of E equals MC squared. And hey, but that's the thing about it, people don't realize. The proof for E equals MC squared, I've got 18 frames, really 17 frames on it. Anybody with college level competence, high school level competency can understand it. It's drawn off of the pendulum concept. So, the guy practiced what he preached. Yeah. I'm getting ahead of myself. Some of the consequences of special relativity that I found interesting. The speed of light is 186,000 miles per second, and no physical object can go that fast. Simultaneity does not exist for two observers if one is in a state of uniform motion with respect to the other. Let me give you an example. If you had two twins born at the same time, one of them flew to the moon and back in a high velocity rocket, when they got back, the one who had gone to the moon and back would be younger than the other one. That's the way it works. Velocity slows down time. Number three, as the velocity of an object increases, its mass increases, its dimension in the direction of travel decreases, and its time frame, the clocks, as I said, slow down. And the last one is mass and energy are equivalent. That's the E equal MC squared proof that I mentioned. And let me say this. That is also, I'm going to mention some things about his impact on atomic energy and the atomic bomb. And you're going to find that some people felt like he was malicious about that. I'll show you that he wasn't. I'll show you that he had good intentions for everything he did. Now, some of the consequences of general relativity, it is so much more complicated than the special relativity because it deals with four-dimensional space. In other words, they add the time factor. And it deals with points all through that space. Some of the results are the path of a light ray is deflected parabolically by mass or gravitational pull. With respect to a large mass, time passes more slowly at a low altitude than at a high altitude. Now it would be infinitesimally small, very, very small, but time would pass slower than somebody in a valley than it would for somebody on top of Mount Everest based upon that. Thirdly, the discovery of black holes, in other words, massive stars that are collapsing at the speed of light, and for which the gravitational fields are so intense that nothing, not even light, can escape them. Light cannot even escape a black hole. If you went into a black hole, just to tell you its strength, it would shred you. It'd pull your feet off, you know, if you could go in feet first. If you could go in feet first. Well, I'm really smooth tonight, hitting the microphone. And if anything that goes into a black hole, mass, energy, and momentum pass into, this is physics theory, another four-dimensional space. See, they say four-dimensional because they throw in the fourth dimension of time. That's kind of mind-catching. And finally, as you could well imagine, he did come up with a new model for the structure of the universe. They named one of the chemical elements after Einstein. It's called Einsteinium, and it's a synthetic element. In other words, it's one that's concocted, developed, with the symbol ES and the atomic number 99. Uranium is 92. I'll tell you more about that shortly. The atomic number matches up with what we call the atomic weight. And if you look at the chemistry chart, you see that table of elements, it has all that on it. The 99 means that under 99, the atomic weights of all of those under 99 are less. As you increase, the atomic weight is greater. And that's been added to the periodic table of elements. And Einsteinium was discovered as a component of the debris of the first hydrogen bomb explosion in 1952 and named after him. It's a soft, silvery, paramagnetic metal, which means it's not really affected much by magnetism. It's extremely radioactive, means that it is exuding energy particles. I say here, like all synthetic transuranic elements, what that transuranic means is that any element that has a greater atomic weight than uranium is called transuranic, and it's referring to uranium. And the atomic weight of uranium, for instance, is 238, and Einsteinium is 252. And notice, for E equals mc squared, that's why they use those elements to make the bombs. With the greater the mass, the greater the energy, with less velocity. You end up with more energy with that greater atomic weight. You don't need as much velocity. So theoretically, it's easier to come up with. Now, a little bit of history on Einstein. Born in Germany in 1879, earned his doctorate degree in 1905, became a professor at the University of Berlin 1914, renounced his citizenship in 1933, became a United States citizen in 1940, my birth year, but he was about 6 months later. And I don't think that my birth had anything to do with his making the decision. I'd like to be able to tell you it did. In 1945, he retired. In 1955, he died. Here's a photo of him receiving his certificate of American citizenship in 1940. Here's another photo. They said 1905 was his miracle year, but it's the year he published most of his important scientific papers, which included the theory of relativity equal mc squared. And I love this quote of his, and this is typical. The guy had a great sense of humor. He said, if my theory of relativity is proven successful, Germany will claim me as a German, and France will declare that I am a citizen of the world. Should my theory prove untrue, France will say that I'm a German, and Germany will declare that I'm a Jew. Here he's lecturing in 1921. Here he is receiving the Nobel Prize in Physics. Here he's delivering his Nobel lecture to the Nordic Assembly in 1923. Here's something I didn't know until I got a hold of this particular book. He fled Germany in 1933, and he lived in that little cabin for a while. Yeah, went into hiding in England. Here, now, I made this statement that he saved a lot of lives in World War II. I'm going to get around to that, and here we're starting off a little bit here. Here he's sitting with physicist J. Robert Oppenheimer, who followed in his footsteps and took over as the senior professor at Princeton Institute for Advanced Study after he resigned. Now, Oppenheimer is the guy who took over the big atomic nuclear project in Los Alamos. So there'll be more on that. Here's another photo of him with a colleague named Leo Szilard, and this Szilard encouraged him to write a letter to President Roosevelt warning of the dangers of a possible German atomic bomb. Now, I'll mention later on, by the time everything was over and World War II was over, he kind of wondered about what he did, but let me tell you, he did encourage us to do the bomb. And at the time he did that, it looked like, and I'm going to have background this shortly, it looked like Hitler was about to come up with an atomic bomb, and he did not want Hitler to be the only guy in the world with the bomb. And so he wrote this letter to President Roosevelt. Said some recent work on the part of E. Fermi and L. Szilard, that's a guy we just showed, which has been communicated to me in manuscript, leads me to expect that the element uranium may be turned into a new and important source of energy in the immediate future. Certain aspects of the situation seem to call for watchfulness and, if necessary, quick action on the part of the administration. Said, I believe, therefore, it is my duty to bring to your attention the following facts and recommendations. This new phenomenon would lead to the construction of extremely powerful bombs of a new type. He said, I understand that Germany has actually stopped the sale of uranium from Czechoslovakian mines, which she has taken over. That she should have taken such early action might perhaps be understood on the ground that the son of the German Undersecretary of State, von Weizsäcker, is attached to the Kaiser Wilhelm Institute in Berlin, where some of the American work on uranium is now being repeated. So that's what he was concerned about. And so in 1940, the U.S. began work on this, and they sent the scientists to Los Alamos, New Mexico. Robert Oppenheimer worked to turn these materials into a workable atomic bomb. And what they did, they used both plutonium and uranium. And when I talk about the bombs at Hiroshima and Nagasaki in a little bit, it'll make another point. Now, at this point, here's another reason that Truman felt that he should probably go ahead with the development and the use of the atomic bomb. Douglas MacArthur advised that if they had to invade Japan, with non-nuclear invasion of Japan, he estimated American casualties up to 1 million. And in order to avoid such a high casualty rate, Truman tried to make decide over the moral reservations of Henry Stimson and Dwight Eisenhower and a number of Manhattan Project scientists to use the bombs in hope of bringing the war to a quick end. And they thought also it'd give the U.S. a dominant position, but I don't think in the world as a result. I don't think that was really in his calculus on that. Let's see, there was one other thing I wanted to mention. Ironically, I use a treadmill about 5 times a week, and I got a little small TV on the wall I watch. Today, I was watching the History Channel, and I'll be darned. I've got some estimates of potential casualties for the Japanese in an all-out war rather than what happened with our atomic bombs. And I was doing conservative estimates. The History Channel wasn't nearly as conservative as what I was thinking. But what happened was on August the 6th, 1945, in Hiroshima, they did the little boy bomb. That was a uranium core bomb. Had atomic weight of 238. In that bomb, there were 160,000 casualties. On August the 9th, Nagasaki, the Fat Man, they named that bomb the Fat Man, and they had 80,000 casualties, so that was a total of 247,000 casualties. Now, in September the 2nd, 1945, we had the Japanese surrender. And incidentally, if you've ever gone to Hawaii, and they have the battleship Missouri next to the Arizona Memorial, and I've taken that tour 3 or 4 times. But one time was so interesting because when they went out on that part of the ship where MacArthur accepted the surrender at this table, the guy pointed out that what they had done to prepare for that, they just pulled one of the tables out of the mess hall. And so they had the ceremony, and then when it was over, they threw the table back into the mess hall, and people were very disappointed because in all their tables in the mess hall, they don't know which one it was, and it'd have some historic significance if they could find it. Now, those bombings, I said, took 246,000 Japanese lives. And I said estimated net savings of lives compared with a nuclear-free invasion, I said would be 1 million Americans plus over 754,000, because the way I figured it, if we invaded and we lost 1 million soldiers, if they lost, they would lose at least that many. So I was calculating based upon them losing the same amount we did. And that would have left it to be a savings of 754,000 Japanese lives. And the savings of 1 million American lives. But the History Channel estimate, I just threw this in today, is 1 million Japanese defenders. Those would have been the soldiers that would have died, and then they were talking about as many as 6 million of the regular population. So, those are all estimates. But the basic theme here is there were a lot of lives saved in that war as a result of what we did. This was kind of an unfair description of Einstein that made it look like he was going around trying to get everybody to use the atomic bomb. It's a July 1946 issue of Time. Here he is kind of clowning it up. Here's the announcement of his death in 1955 at the age of 76. 2 points I'm going to make here, and this is kind of a personal point, but I think Einstein pretty well followed these guidelines. Science can only determine how things work, but not why. Now, I read that in a book. I'm trying to remember the author, years ago, sometime in the 80s. He said that, but he didn't back up why. I have a good friend. He and I were in the Scouts together down in San Antonio in the 50s. We went to Big Bend on a scout trip for 2 weeks where he and I shared a tent. He ended up getting his PhD at Rice and being one of the main scientists chosen to analyze the moon rock when it was brought back. Dr. James Carter, he retired from UT Dallas fairly recently. And I've got pictures of us in that tent, and I tell him it's proof positive that I'm smarter than he was, because I was sleeping on a cot and he was sleeping on the ground. And there were a lot of rattlesnakes around there. But I made the comment, I said, hey, science can only determine how things work, not why. He said, I don't agree with that, and I give the guy credit. I said, well, absent knowing why space, matter, and energy exist and behave as they do, no comprehensive whys can be given for any resultant phenomena. And after I said, he said, you know, you're right. You can't give totally comprehensive whys. Number two, as a matter of objectivity, scientists must operate on the assumption of the non-existent of that which cannot be observed or measured. Einstein didn't subscribe to any particular religion, and most scientists won't, because they don't want to be accused at any time of believing something they don't have evidence for, positive evidence. So you see some of that. Although I think that many of them, if they did have, they out of a professional standing, they stay away from talking about it. Einstein, I'll just kind of summarize, he basically said that in terms of any explanations for any kind of phenomena, he always felt that a single one has always proved itself to be superior to all of the rest. In other words, superior to combinations of more than one justification. I think that had some implications for his concepts of intelligent design, which he'd never used that terminology, but I'll point out some things he said later that are similar. And he made the statement that nobody that has really gone deeply in matter will deny that in practice the world of phenomena uniquely determines the theoretical system. And he goes on to say, this is what Leibniz described so happily as pre-established harmony, and that probably is an allusion to what we would say is intelligent design. Okay. On conformity, I got a kick out of this statement. And I'm sure that he didn't mean to be insulting of band members, but he said, the man who enjoys marching in line and file to the strains of music falls below my contempt. He received his great brain by mistake. The spinal cord would have been amply sufficient. That's the most uncompromising statement that I've ever seen him say in any book, but I thought it did sound funny. On the mysterious religion and spirituality, got a few comments there. The deep emotional conviction of the presence of a superior reasoning power, which is revealed in the incomprehensive universe, forms my ideal of God. he kind of gets around the side on it. He made the following statement: I am at any rate am convinced that he is not playing dice with the universe. Here's another statement that where he's just coming in from every angle. Everything is determined, the beginning as well as the end, by forces over which we have no control. It is determined for the insect as well as for the star. Human beings, vegetables, or cosmic dust, we all dance to a mysterious tune, intoned in the distance by an invisible player. To know what is impenetrable to us really exists, manifesting itself as the highest wisdom and most radiant beauty which our dull faculties can comprehend only in their most primitive forms. This knowledge, this feeling is at the center of true religiousness. In this sense only, I belong in the ranks of devoutly religious men. He made the statement, what is the meaning of life, or for that matter, the life of any creature? To know the answer to this question means to be religious. You ask, does it make any sense then to pose this question? I answer, the man who regards his own life and that of his fellow creatures as meaningless is not merely unhappy, but hardly fit for life. Made the statement, science without religion is lame, religion without science is blind. I'm just trying to throw all these comments he's made so you can kind of get a feel from where all he was coming from. He says, my religion consists of an humble admiration of the illimitable, superior spirit who reveals himself in the slight details we are able to perceive with our frail and feeble mind. Here's a compliment he made to Judaism and Christianity. He said, if one purges the Judaism of the prophets and Christianity as Jesus Christ taught it of all subsequent additions, and by that I'd say rituals and whatever, especially those of the priests, one is left with a teaching which is capable of curing all the social ills of humanity. Then when he looked at religion in general, he said there were 3 levels or stages of religion. The first one is fear-based religion. The next one, he said, was morality-based religion. And the third one was cosmically religious-based religion. I'll give some insight, his insights on those. Obviously, fear-based religion is religion evoked by fear of hunger, exterior forces, sickness, and or death. In other words, I'm exercising that one when I say, oh, if I'm not good, I'll pay for it, you know. Morality-based religion is religion evoked by a desire for guidance, love, and support. In other words, a providential God which protects, disposes, rewards, punishes, loves, comforts, and preserves the souls of the dead. Now, he said with respect to fear-based and morality-based religion, he felt that all religions are a blend of both types with this differentiation, that on the higher levels of social life, the religion of morality predominates. And here's his definition of cosmically, religiously felt religion. It's evoked by the individual's feeling that individual existence impresses him as a sort of prison, and he wants to experience the universe as a single significant whole. He stated that the beginning of this appeared in many of the Psalms of David. I never did check to see which ones those were. Let me see. I'm going to try to match what I've got here with that. That is religious levels. I just got through. Did I? Yeah, here we go. I had one more. A man's ethical behavior, he said, should be based effectually on sympathy, education, and social ties and needs. No religious basis is necessary. Man would indeed be in a poor way if he had to be restrained by fear of punishment and hope of reward after death. I like that. outlook on that. He and his wife presented in 1932. They presented a Bible to an American friend, and the inscription went as follows: "The Bible is a great source of wisdom and consolation, and should be read frequently." With respect to what he said, here's a contention I might have, and that would be that if there is a deity and if there is a judgment, a deity wouldn't be so shallow that he viewed somebody as being good just because they were responding to a reward system, you know. And so I said, with no existent accountability. So he would be asking, what would this individual do if with no existent accountability, not a robotic response to a reward system? And the greatest creation that a God could create would be an individual that replicated the deity's values to the greatest extent humanly possible. I call it the Godkin concept. Godkin is just my own idea. Here's a picture of him as we generally remember him. Now I'm going to go into his ethics. That was kind of some views on his religion. In terms of ethics, he said, only a life lived for others is a life worthwhile. He said, nationalism is an infantile disease. It is the measles of mankind. Yeah. I think that he would agree that democratic republics with bills of human rights are something you can support, but you don't, as happened with Hitler. And this is what I saw on that History Channel today, that the German army in World War II, 30% of their financing came from wealth they took from the Jews they had killed and whatever. 30% of their war machine was paid for by the Jews they had murdered. So Hitler had another ulterior motive. The world is a dangerous place to live, not because of the people who are evil, but because of the people who don't do anything about it. Weakness of attitude becomes a weakness of character. Strive not to be a success, he said, but to be of value. And no matter what level of job you've got, if you're doing your best to serve others, that's, as I interpret this, where he was coming from. Here's another one that I love, because he was very humble in everything he was given credit for. Desire for approval and recognition is a healthy motive, but the desire to be acknowledged as better, stronger, or more intelligent than a fellow being or fellow scholar easily leads to an excessively egotistical psychological adjustment which may become injurious for the individual and the community. He's very humble. He said, I have no special talent. I'm only passionately curious. He said, I believe that the simple and unassuming manner of life is best for everyone, best for both the body and the mind. And he really practiced it. If you ever saw videos or movies that had him in it, he was a very humble guy and unassuming. He said everyone should be respected as an individual, but no one idolized. And he was really speaking about what they were doing with him. And maybe talking to me. Pleading guilty here. He said, isn't it strange that I, who've written only unpopular books, should be such a popular fella? Now, this is one I could not find the source on this. But I've got a quote that I think pretty well parallels it. And I think that there's some people who question Einstein actually having said this, but I like it so much, and because of what he said that I'm going to show you shortly, I think it parallels what he was thinking about. He said, I fear the day that technology will surpass our human interaction. The world will have a generation of idiots. That's my job. I usually do that. Here, I'll give you some napkins. Here's a bunch of napkins. Yeah. How many times do you have speakers that are ready with the napkins? And I stopped to think, and I got a smartphone, so I'm guilty of it more than I want to admit to, but people walking around looking at their darn phones all the time. And here's a statement that I think will blow everybody's mind. And I think when he said this statement, it applies to looking at your smartphone too much, because you're usually reading. He said, any man who reads too much and uses his own brain too little falls into lazy habits of thinking. And in his youth, and here's where I think he was coming from partially on this, because his thought process he used early on in physics led him into this concept of the speed of light and all this type of stuff. In his youth, he was especially enamored of the basic math text, his holy geometry booklet. At 16, he devised one of his first thought experiments. These can only be done in the mind, not in a laboratory, and eventually lead him to his stunning theories. In this case, he imagined what a light wave would look like to an observer riding along with it. To one question as to the speed of sound, he replied, I don't know. I don't crowd my memory with facts I can easily find in an encyclopedia. Yeah, that's the speed of sound. Virtually everybody knew it. But, you know, his thought processes were very different. I mean, the idea of coming up with E equal mc squared with nothing but a pendulum is so simple, but nobody else ever thought of it. He related energy and mass by comparing potential energy and kinetic energy at various points on the pendulum. When the pendulum was at its high point, the kinetic energy was zero, the potential energy was the total. When it was at the low point, the potential energy was zero and the kinetic energy was at its high point. So he compared the two and equations and came up with that. And what's ironic about this, I ran into this in it was not given that well in his relativity book, the total proof. So it was years later when I read his book, Ideas and Opinion. But I went, and I thought somewhere they were putting two equations together, and I talked to a PhD physicist at a very reputable institution, no names mentioned, and I said, do you know which equations that he put together, two different equations, combine them in such a way he could come up with the equality? And he said, no, but I could look it up. I never heard from him. But anyway, and then I run into it in Ideas and Opinions, and the proof E equals mc squared can be understood by anybody competent at the high school level. He had a taste for education and stuffed young minds with facts, names, or formula. He said they didn't need to go to a university to learn that. They could get it out of books. His statement was, education should be devoted wholly to helping young people to think, to give them the training which no textbook can provide. It's truly a miracle that modern education hadn't completely stifled the sacred curiosity of research. And like I said a little earlier, I've been fortunate enough to have been around some nationally prominent professors in some national organizations, and boy, the ones that have been very productive, they're always non-threatening, down to earth, confident. You know, I have a theory that all undesirable behavior is rooted in insecurity, But the profs that have really produced and are totally secure, they're really laid back, and I've been very impressed with some of them. Yeah. If you can, and this is what I think every college ought to tell their professors. If you can't explain it simply, you don't understand it well enough. And he did that with E equals MC squared. I was able to understand it. Any intelligent fool can make things bigger and more complex. It takes a touch of genius and a lot of courage to move in the opposite direction. It's a miracle that curiosity survives formal education. And as he said, you know, he felt his strong point was curiosity. He said, make everything as simple as possible, but not simpler. Now, I think I threw this in earlier and didn't erase this. Yeah, after I heard that, or put that there. But anyway, that is a surprising statement on his part. It is the supreme art of the teacher to awaken joy in creative expression and knowledge. Most of the fundamental laws of science are essentially simple and may, as a rule, be expressed in a language comprehensible to everyone. Now here, this next statement, I love it, it's funny. I think I'm at the right point now. It should be possible to explain the laws of physics to a barmaid. Okay, here's one, and I think it's really true if you stop to think of, he said, the gift of fantasy has meant more to me than my talent for absorbing positive knowledge. Well, that was fantasy, him thinking about riding along on a light wave, you know. He said it was not wrong to define education as follows: is that which remains if one has forgotten everything he learned in school. Isn't that surprising? You'd hear him say that. I love this one, and there's another one to follow. The difference between stupidity and genius is that genius has its limits. Only two things are infinite: the universe and human stupidity, and I'm not sure about the former. Gravitation is not responsible for people falling in love. When you're courting a nice girl, an hour seems like a second. When you sit on a red-hot cylinder, a second seems like an hour. That's relativity. Here's a statement that I think applies to him and applies to something that we said earlier in the religious part. And I think most Christians are surprised to know. This is a verse in the Bible, Romans 2:13. And basically it says that there's some people who've never even seen Christianity or the laws, but they're a law unto themselves, and it says they'll be considered righteous too. So, you know, I think of that, you know, if Einstein was a law unto himself, he'll be considered just as good as any of the rest of us, you know, just as righteous if there is a deity and a judgment and everything. But this one said, and this explains, because a lot of people said, well, hey, if that's true, what was the story before Christ came and existed? What happened to those people? Well, if they were a law unto themselves, according to this verse, they'd be okay. So, gee, folks, there were 79 of these, and believe it or not, we made it too. I was worried about it. Hope it didn't put you to sleep. And now, let's see, we're answering questions if people had them.
Where's the talking stick?
I tell you, how you doing that? I'm going to put something on the beginning of the heart.
Let's see if this is, yes, it is active.
Who wants to be first?
Actually,
Actually, my question is this. I'd like you to go back to one of the first slides that had some stats on it about the speed of light.
Okay. Let me see.
There were a couple other things on that slide that I missed.
Okay. Okay. When you see it, let me know, okay? The speed of light. Okay, wasn't in the ethics, I don't think.
It was way back there first.
Oh, okay.
When you started it.
Oh, okay, yes, of those results of special relativity. Okay, here we go.
The one before his photo.
Is it? Did I miss it?
Yeah, before. Right before. There you go. Thank you.
Oh, no, this one.
That one.
Oh, okay. Now, on that, I will qualify that Earth's axis being 1,000 miles an hour. The farther you are away from the equator, it becomes less. Yeah. To where if you're at the North Pole, it's virtually zero. Yeah.
Could you say that that's kind of like when you're on a seesaw? You're traveling much faster at either end than you would be in the middle?
Well,
when you're on a pivot?
A similar deal, because in the middle, that's right. It's very similar, except that it's spinning, and up at the top, it's just spinning on the axis.
Right.
Yeah.
Okay.
Yes, sir.
I was just going to say it's obvious that if you want to lose weight, move to the equator.
Yeah. Okay, I'm going to try to, while you're come both the questions, I'm going to try to get over here and start out that E equal MC squared proof, just to give you a picture of the, but however, somebody might have a question, another question about one of these, so I guess I'll do it at the end. Is that okay? But I did want to show you that simple concept. Any other questions?
I was with the Institute for Advanced Studies in Princeton, and the reason why no one really wanted to get involved with religion was because every scientist, when they came up with an idea or something, it could be used for good and evil, and they knew it could kill people or it could benefit them, and they were wrestling with that, and that's why they decided that they would leave religion out of it completely, because this was a huge factor with these scientists.
Yeah, and the thing is, they come to conclusions. No conclusions are made in science that cannot be observed or measured.
Right.
Yeah.
And
If you get into conclusions that are not based on something you observe or measure, then you're moving into religion.
right. And they would always have these big signs, think. In other words, that was their main objective, was to think. Not to learn, but to think. And if you could think, you could conquer the world,
Right.
so to speak. And this is,
Okay, well, as soon as if there are no comments.
I have a question. Okay, so what we're doing in schools now by teaching to the test from first grade to 12th grade, what do you see as a professor, what do you see that we could be doing differently rather than the series of fill in the bubble on a multiple choice test?
You know, I'll tell you that. A friend of mine that just died, that I did the eulogy for, was a chemistry prof, and he hated multiple choice tests. He spent his whole life fighting because there's no room for creativity responding. There might be some instances where it'd be helpful. I've never been an advocate of them. I can't really think of instances where I've used them over 1% of the time.
So what could we be doing differently?
Well, if you can identify answers that can be given that are not multiple choice, that are verbal to describe various principles and what have you, then maybe those are legitimate testing questions, you know. But when you have multiple choice, see, if you've got 4 items on a multiple choice test, well then, for somebody that doesn't know anything, they got 25% of the points in the bag. Yeah.
But usually you have to prove your answer and then go back and highlight maybe the question, or usually the statement that kind of says something where you can find the answer.
Well, if they do that, that's better than just the standard multiple
My
choice.
taught school, and even now, my substitute teachers, they have to prove it.
Well, hey, with instances like that, you've covered the bases pretty well with that type of.
And there's some that you can't really prove. I mean, you just choose, you know.
Yeah.
But most of them want you to
Yeah,
prove it.
you know, teaching math, I didn't have that many opportunities, but there are probably fields that are different than what I taught.
Well, I've been, I studied, now, it's very important with multiple testing, because number one, this encourages the brain to think. In other words, eliminating certain things. This encourages the synapses of the brain to multiply. And you have to figure out your reasoning. And by figuring out your reasoning, your brain expands to learning more.
Right.
And this is why they have a lot of multiple, questions for the
Well, I'm sure there are instances where it has good applicability. But I know this in science. My friend was complaining about the fact that there were some science courses where they were doing 100% multiple choice.
Yeah.
And nothing but multiple choice.
Oh, well, that's not, yeah.
No.
Well, what they do with multiple choice, like EPS and Educational Testing Services, it was not only to find the correct answer and who had the correct answer, but how they came about the
Right.
answer. And it was thinking out of the box that they discovered a lot of children that were actual geniuses, and they did go on to become geniuses.
Right. Well, Einstein had to go back to a prep school to get into college. Yes, sir.
Years ago, I was working for the American Institutes for Research out in the peninsula in California, and it was run by a lot of highly credentialed PhDs in education. And they were writing this program. I was talking with this one psychologist one day. They were writing this program that would be a complete high school educational system done in multiple choice. And so I looked at this guy and I said, now how can this possibly teach creative writing? He said, oh, well, we'll give them alternative choices of paragraphs to assemble. And, I figured that I had seen the epitome of the dumbing down of America in that statement. And I also, what I was doing out there was programming in COBOL. And COBOL is a very English-oriented language. If you need for it to do this task and then go over to this task, you give that task a name like sum the results. And so my boss handed me this project to do, and he had all these paragraphs that you go to that were like X34Z-9. And they were all like that. And I started trying to put it all together to go to these addresses, and I just got so frustrated. I said, to hell with this, I'm going to write it like it should be written. Wrote the whole program, tested it out, got it running, and so forth. And it had clear English statements in it, and I took it to him. And as far as I was concerned, if he didn't want it, I didn't want to be there anymore. And so I gave it to him, and he said, well, I see what you've done, and go ahead and do it that way. That institute was largely supported by the CIA, I later learned. And had I known that, I never even would have gone to work for them. But if you have multiple choice, you already give them some sort of solution rather than having them start with a problem and come out with a totally creative solution of their own. Anyway, that was my result.
And if they're going to talk about a topic, sometimes they need to know the names without seeing it on a multiple choice.
I just had a question about the concept of the number of lives spared using the bombs.
Yes.
Well, I noticed that they were talking about basically just the people that died from the immediate
right.
result.
Right.
What about the people that died from the long-term consequences of the radioactivity and all the healthcare costs and all of that? I wonder, because I mean, the resulting lasted a long time.
Well, that's very true. And I'm trying to think, I've got to go back. I don't know if I had my source listed on that or
Bet there were a
not.
lot more people that died
But
afterward.
I would have to think that would be true. Yeah, I don't know to what extent they included that, but I'm sure there were things that happened years later that they weren't really sure about.
Right, because I don't think they understood the long-term consequences.
Oh yeah.
They just knew that it would kill people like instantaneously, but they didn't really understand how the long-term effects of the radiation would affect the healthcare and instance of cancers and all the other things that we now know is related. Just a thought.
Like bone diseases,
Could you talk a little bit more about psychometrics? You mentioned that it was psychological
statistics, yeah. I studied at the University of Hawaii at Manoa, which is on Oahu, under a guy named Dunrankin, who wrote a book entitled Scaling Techniques, and another one named Dan Blaine, who got his PhD at UT Austin and was also on the faculty there. And in mathematics, let me tell you this, in mathematics, the statistics taught, like when you're working on a master's and what have you, it's all theoretical and not really an opportunity for a lot of applied. So I loved the psychometrics because you could develop your ability to work with applied, and especially like scaling techniques. The practical applications is what I was searching for when I went back to Hawaii. Yeah.
What do you mean by scaling techniques?
Okay, that's like rating things from 1 to 10 or stuff like that, and the development. This guy had the theories on the development, and sometimes it's just true or false, all kinds. But that book is by Dunrankin, so if you ever traced it out, it'd be easy to find, because DUNN-RANKIN, because that's an unusual name. Yes, sir.
One of those statements up there, I, for years, have completely disagreed with. I have just a bachelor's in physics, so I'm really hardly qualified to have opinions.
No, that's not right. I'll tell you, a lot of people, a lot more with high school degrees that have been self-educated and smarter than a bunch of us walking around with doctorates.
Well, I totally disagree with the worldwide theory of the Big Bang. And they say that it is because the farther out you see, the more there's the Doppler shift of those things appear to be going faster and faster and faster. But what they are basing that on is the belief that the universe is empty space, and it's not. It is densely filled with energy of many types that we will have centuries to learn what all it is yet. And even light can be seen to be bent in its path as it goes past a gravitational field of a body out there.
Right.
It's affected by what's out there. And so, in my opinion, that light is being progressively slowed down over those distances more and more and more.
Yeah. Well, they're coming to these conclusions about velocities, as I understand it, primarily by analyzing what they call redshift. But a follow-up to your idea about the Big Bang Theory, and here's a question I have for physicists. They talk about the Big Bang and it expanding. the universe is expanding, okay? So my question is, okay, let's say we're expanded out to where my hand is. What is it expanding into? Is the space a part of the bang expansion, or is there space out there to begin with? And if there is space out there to begin with, and I have 1 cubic foot of it, do I have some chemical elements in it? And nobody's answered that question for me.
Well, to me, it's infinite. I don't see it any other way.
Infinite, but okay, infinite. So you're saying the Big Bang is exploding into an infinite space?
No, I don't believe in the Big Bang at
Okay.
all. I think the universe is filled throughout itself with an infinite variety of star systems and life forms, and some far more intelligent and more spiritually developed than we are on the earth, and some less, and so forth, just like we are. I think there's an infinite variety out there.
Yeah, well, yeah, I don't know how cosmologists, it'd be difficult to measure, come to this conclusion, but what they're saying is, based upon their analysis of the universe, everything is moving away from a single point.
Yes.
And that's how they come to that conclusion. I don't know how solid their evidence is of that, but evidently they've got some, because they've sold that to a big bunch of people.
And where is that point?
Yeah, well,
It's right here. That's the thing that is the total fallacy of it. It appears that right here is where it took place. And everything is going out from us in all directions the same way. But if you moved way over there, it would be the same. Because the Doppler shift is created by the friction, the interaction of energy and particles of light. Light is like, I use the term bundicle. It's a bundle of energy and a particle in its nature, because it shows the qualities of both. And there is a physicist, a lady, who developed a chamber as long as this room is wide, and I've seen videos on it. She shined light into it, and it held the light stationary in that energy field, and then she turned off the energy field and the light continued out the other end. So,
yeah. Well, I don't know how they conclude it, but according to, and how they, I look up in the sky and I wonder how they even know where the planets are and going around the sun. I don't know how they came to all these conclusions. Cosmology is something that boggles my mind. But according to what they're saying, these constellations and the Big Bang, not the Big Bang, and the Milky Way that we're in, galaxy, they're all moving away from a certain point based upon their observations. How they come to that conclusion, I couldn't tell you.
well, it's the Doppler shift. The farther away something is, the lower the frequency of light, because it's like the train coming at you has a higher tone than when it passes you. And the faster it goes away from you, the lower that tone drops. And that's what they're finding, is that the farther out an item is, the more there's the drop. So they think in an explosion, those farther out items were blown out first. They're going faster. But I don't think that's true at all. I think it is the slowing down of the light over the distance, and it's progressive in every direction.
Yeah,
and that Big Bang seems to have taken place from where we are. And the theory of it totally discounts the fact that, they can't find 94% or so of the so-called dark matter. Space is densely filled with energy. Densely filled with energy. And it interacts with the light and slows it down.
Including black holes, according to the cosmologists.
Well,
which I don't understand.
Well, to accept the belief of a black hole, which no one has ever proven, you have to accept the belief that gravity is a pull exerted by mass. But there aren't really pull forces in nature. They're all kinetic energy. If you take what's called a Kirlian photograph of a magnet, you'll see what looks like fire coming out of each end. Because of the orientation of the molecules, energy is flowing in one direction through it in one way, and another type of energy in the other direction.
Well, it could be that gravitation is a form of that type of energy.
I think gravity is a dynamic, probably, who knows, infinite speed of energy that fills all space. It's like a dynamic pressure pushing everything together. And if you had two objects in close proximity, the light, the shadow effect of gravity coming from this direction would not hit the face of this one and vice versa, so they'd be pushed together. And I've taken the equation and removed the mass from it and put the cross-sectional diameter in it, and you have a working equation.
Well, gosh, all I know is I've not heard that theory before, and cosmology's way out of my league, but basically that's the theories they have now, and they do believe in the Big Bang. And
yeah,
I don't know how. Evidently, the Doppler shift, and I've said the red shift too.
That's the same thing.
Yeah, same thing, or what they're coming to conclusions about, and like I say, it would boggle my mind to look up in the skies and come to any conclusions at all. Yeah.
Well, let me ask you one other thing that has been classically taught to us, and you can go to National Geographic and you'll see a cutaway of the Earth representing a ball of molten iron in the core.
Yeah.
How can anyone believe that? What does heat do? Heat goes towards a colder direction. If for millions of years we had had the temperature of molten iron at the core of the Earth, that heat would have come to the Earth, evaporated all the water, driven most of the atmosphere away, and made it unlivable for any form of life at all. That's the most ridiculous theory I've ever heard in my life.
But the airplanes flying at this airplane going to Hawaii, they mentioned that outer rim is like, what was it? The kid lived through 76 degrees below zero. So there is cold out there, and they're evidently coming together, and we're just in the balance between them. There's a schematic for the proof. He just used a simple pendulum, and up here, when the pendulum was at its high point, his potential energy is at a maximum, and that has to do with mass, and the energy is based upon the mass. When it gets down to the low point, that's momentum. So that is kinetic energy, and that deals with velocity. So he's able to equate the two and come up with energy, mass, and velocity, and it's energy equals mass times velocity squared. So yeah, the maximum speed of light. If you'd like to, I could go through that. There are 18 slides if anybody wanted to see it. Some of you want to see it? It's not that complicated. I'll do it real fast. Okay, I've already said what the scheme was. I'm violating the rules here. I'm getting out of the microphone. They need it for the YouTube. So we've seen the scheme. It's analysis of theoretically resistance-free, simple pendulum at its highest and lowest points. These were things that were already proved, and I mentioned those to you today. All of these we've mentioned. This is the terminology. If you'll notice, there will be times when I use like a small m, that'll be an amount of mass, and if you see a capital M, that'll be a maximum amount of mass. When I use capital letters, it'll be a maximum, like H for height. I said potential energy is simply stored energy due to the position, in this case gravitational pull. Kinetic is due to motion of an object. At point A, you have potential energy, maximum potential energy, but the kinetic is zero. At point D, you have maximum kinetic energy, but the potential energy is zero. But the point is, no matter where you are on that pendulum, the total energy stays the same. So that means we can set the description of the energy at 2 different points. And so there's potential energy is mgh, mass times whatever the gravitational pull plus the height, and kinetic is m times the velocity, mass times velocity over 2, but squared over 2. And there's the total energy. It'll be both of them. And then I said you set them equal to 0. Then remembering that the laws of conservation of mechanical energy and equivalence of work and heat, that the total must be the same value for any position on the pendulum. At point A, you got kinetic energy is m times v squared over 2 equals 0. At point D, mgh equals mg times 0. The height is 0, and so it's all 0. Therefore, you have by the transitive property equality, you have mgh is equal to m times v squared over 2. And if you let capital M be small m divided over 2 and solve those 2 equations, you get E is equal to m times that maximum mass times maximum velocity squared. And remembering that c is a limiting velocity, it can never be equal to c, so that energy will always be less than E is less than mc squared. But Einstein concluded, because that was so small and for understandability, there's no limit as to how small the difference would be between E equals mc squared and E slightly less than mc squared, so he just stated as E is equal to mc squared. So that's the most famous scientific conclusion in the history of the world, probably. And yet, look, he used a pendulum to do it, simple pendulum. And so he was thinking, somebody said, we're talking about thinking about outside the box. That's exactly what he was. Just like thinking about being on a light beam and what the things would look like if he were riding on it. Well, I believe that's it. Anyway, I took you through that real fast. Trying to prove the what theory?
Trying to prove his theory.
This theory? I'd never heard any problems with it.
It was the Philadelphia experiment, where a battleship in the Philadelphia Navy Yard actually disappeared with people on it. There were a few, because it was in mothballs or something. I don't know.
Gosh, I don't know anything about that. But now we got a plane that disappeared.
Yes. And when they brought it back, there were several people that were supposed to be on it, and they wondered if it actually disappeared and came back to reality, because they were trying to prove his theory.
Gosh, I don't know anything about that.
Did you know about it?
Well, there was a movie made about it. Yeah,
okay,
people were like half inside on the side. Their legs would be sticking out at the side of the ship and all. They moved in time, so
okay.
They were trying to move forward in time, I think.
Oh, I didn't know anything about that.
Wow. Yeah, they were trying to figure that one out. And it was very hush-hush.
Okay, well.
Any more questions?
Are you familiar? Are you familiar with Fred Allen Wolf?
Not offhand.
He's a physicist.
No.
Yeah,
I
he's
don't
pretty
recall.
interesting. But yeah. Well, I don't know if that's what he wrote that. But
What did he write?
what's that?
You say he wrote something?
Yeah, he wrote some books. I'm trying to remember a couple of them. Yeah, he writes about quantum physics and how the individual affects their reality. And he kind of brings in a personal perspective into quantum physics. But, the quote you had up there about God doesn't play dice with the universe.
Right.
That, I think Einstein was making that was a response to him with those that were following the theory of quantum physics there.
Right, right.
Am I correct on that? Yeah, and I think.
And he
that's
worked
what-
with Max Planck on that.
Right, and they were going back and forth on that apparently. And I don't think that now you look at PBS, you look at all these programs coming out, they're all kind of going into string theory now. They're going into all kinds of complications of all this.
Yeah, I've done
Trying
very
to-
little reading, but when I did try to understand what the definition of quantum was, I don't think I ever picked up on it. It's
They were trying to reconcile the theory of relativity
Right.
with some other things as well. They're trying to get this big picture thing going, and so apparently, but I know it was going back and forth.
well, Einstein was dealing with that with Planck, and evidently, he was exploring the idea too. But that is really
goes pretty
really deep.
Yes,
really
it is.
deep.
You can spend hours
Yeah.
talking about it.
What I've read, I walked away having forgot it.
Right.
If I ever really halfway understood it.
Right. Fred Allen Wolf's, he's got some interesting things. He talks about these people, when you talk about time, you're talking about personal time.
Right.
And how a yogi can go into meditation and
Yeah.
somehow they lose time or some sort. And they go into this altered consciousness of some sort. So in other words, the individual themselves is a part of this universe and also is impacting it all the time. So it's a whole, as you get into the subatomic level of particles and all this other stuff and how we impact it, it gets pretty complex.
Yeah. I'm sure there's so much out there we really don't understand.
There's a lot we really don't understand.
Could you go back to the point that you made by the reference to the couple of verses in Romans?
Yeah.
And how you see
Yeah,
that
well,
fits with-
basically, what I remember about that is that it makes the statement that there will be some who are a law unto themselves, and they will also be considered righteous, which means that there's some people, Christianity, based upon that verse, believes that there are people outside of Christianity that live righteous, doing basically. Christ said two verses sum up all of Christianity. Love the Lord your God with all your might. And to me, that means ascribe to his identity. The only identity we know, according to Christianity, is the principles he laid out. And love your neighbor as yourself. And so with that in mind, to me, my way of thinking, it was saying, hey, if Christianity is truthful in saying there'll be a judgment, that based upon their own literature, somebody that's never seen it will be just as well off as we are, or whoever it is, they are. Yeah. Yeah, so was there anything more to that you were wondering about? But anyway, that was my simple-minded interpretation.
No, I think it's very interesting, and I also subscribe to that belief that, there are people who believe that you must be saved through grace, but, wouldn't it be better that we instead treat other humans with respect and do the things that we know to be right and treat other people the way that we would wish to be treated instead of condemning, judging, and, ascribing blame to those who are supposedly not Christian.
Yeah, and I have the guy that replaced me, it was a very fortunate situation. We were short offices. For 3 years, I got to retire and teach half-time for 3 years, which I wanted to kind of gradually go into. And he was a PhD mathematician. He shared his office with me, and we got to be very good friends. Confucius came along a long time before Christ. Confucius, according to him, said something that parallels. He said, don't treat other people like you don't want to be treated yourself. That's exactly logically the equivalent of treat others like you want to, treat yourself.
Okay, I guess that's it for questions. Now you get to sit down.
Thank you.
And then we get rebuttals. Okay, now it's your turn to talk. So who wants to be first? There has to be a first. I can't believe this. Come on up here, Albert. I knew I'd get him sooner or later. Well, of course you got to say something. It's one of those things.
I have a friend here in Dallas, an elderly lady who, when she was a teenager, her family lived next door to the Einsteins in Princeton. And she used to sit out on lounge chairs out in the yard on nice summer days with him, and the two of them would talk. And one evening, he said, "Now, Sadie, you see up there in the galaxy, you see that star over there?" And he got her to look at a particular star. And then he started talking about the civilization on that star, what the people were like, what their lives were like, how advanced they were, and this and that and the other. And she turned to him and said, "Dr. Einstein, it sounds to me like that's where you're from." And he just turned and looked at her and smiled. It was very interesting. And from what I understand, well, I've always had the belief that thinking is a useful tool that more often than not is in the way. And it is in the way because thinking is so interrelated with our own egos. And we think our thinking is us, but it's not. It's a tool because we can control it. So it's not us. But in order to really have those ideas that come from much higher intelligence than our little thinking minds, we have to be quiet and listen. And I think it was Richard Bohm, who was a physicist, read an interview of him, and it was the editor had just collected interviews of people concerning the brain, intelligence, and all the relationships and so forth, and from people of different fields. And Bohm was interviewed, and he started talking about a thing he called sudden insight. And he said sudden insight can only happen when you can totally cease thinking, when you can get totally silent. And he said even thinking about not thinking would interfere with the process. And he said to him, a physicist, sudden insight completely explains instantaneous healing through prayer. I thought that was very, very enlightening on his part. Einstein used to go into a certain church facility of a Christian denomination, I won't go into that, where people often spend some time studying. He walked out one time and he said to the attendant there, it said, "You know, you people don't even realize what you've got here." So I know that he was a very spiritually minded man, broad in his outlook. Like most of these statements take and erase all of our simplistic definitions of religions. I think religion is one of the greatest plagues on earth to man, because the more killing has been done in the name of religion than almost anything else, and more self-righteousness. In ancient Egypt, there was a goddess by the name of Ma'at, and she taught, according to the priest who interpreted all the things that he heard from her, principles that became national principles in ancient did I say Greece? I meant Egypt. One of them was always speak the truth to everyone. That was a national law. Always treat everyone in a kindly manner. That was a national law. And because of these principles, the ancient kingdom of Egypt, which lasted for 5,000 years until through great immigration it was basically invaded and a revolution happened, they were extremely peaceful and prosperous. And the statement attributed to Jesus of "do unto others as you would have them do unto you" is really copied from an ancient Egyptian version, much older, "do unto others as they would have you do unto them," which to me is a far more spiritually advanced concept, because you're not judging it from your own personal things. You're looking into that person's needs and wants, and you're modifying your behavior accordingly.
You think that's better than the one by the Chinese philosopher?
Which is that?
The one I mentioned earlier.
I don't remember what it was.
Confucius.
Yeah, but
and he said, "Don't treat others like you don't want to be treated yourself."
Well, that's very good.
It's still parallel. So
Yeah.
what you're saying is it reaches out a little further.
Yeah, that is a good "don't do it" part. But I think the Egyptian is the best I've heard of what to do for other people. Because basically, if we're not reaching out to other people, what the hell are we here for?
That's great. What is that source?
From ancient Egypt, the goddess Ma'at.
M-A-H-A-T?
M-A-hyphen-A-T, Ma'at. She was the daughter of one of the high honcho gods and so forth. You know, they had many gods and goddesses in that kingdom. And now, Jesus was once asked by his disciples, why are you teaching these people in parables? And he essentially answered, to paraphrase it, because they're first graders and you're sixth graders. You start with number system and then you go to arithmetic and so forth, and turn that damn thing off, please. And in ancient Egypt, there was a whole array of degrees of understanding. And their head honcho god was Ra, the sun god. Now, the sun is the source of all the light of the solar system. And light is a metaphor for spiritual understanding. They had an organization called the Great White Brotherhood that meant the full spectrum of spiritual understanding in ancient Egypt. And so you had all these different levels of these things that, well, I mean, there's a lot to it. I think Einstein was one of the... Oh, let me just say one more quick thing about Einstein. I read that he worked and worked and worked and worked and worked to come up with E equals MC squared. And mentally, he just couldn't quite get it. You know, he knew he was there, but he just couldn't quite get it. So one night they were in Geneva. He put on a coat and went out in the rain and walked for about an hour and came back chilled to the bone, ran a hot tub, got in the tub, and just zoned out. So he stopped thinking. Boom, there was E equals MC squared.
Okay, who wants to be next? Come on up here, Shelley. Watch yourself. Oh, you're all right. Bye, guys.
Nah. The only thing I have to say is if you want to learn more about astrophysics, there's a great show every Sunday night at 8 p.m. called Cosmos. John and I are totally, absolutely addicted. It is phenomenal. It's it's got Neil deGrasse Tyson, who's a very well-known astrophysicist. It's on Fox on Sundays at 8 p.m. and then on National Geographic Monday nights at 8 p.m. But check it out. You would be very surprised. It actually explains why they believe in the Big Bang, how they're able to determine these things. It's pretty cool. So that's all I have to say.
And don't forget the Big Bang Theory.
Got anybody else? Well, she's got 5 minutes. You come on up here. No, come on up here. Come on up here. Come on up here. Come on up here. We're going to push you on. Yeah, but we went. You don't get recorded. Come on up here.
I was sitting by a scientist using his little computer on an airplane and all this interesting stuff on it. And he said he was a scientist and all. Told me, I forget where he said he was from. But I said, well, what are you studying? He said, well, we're studying 19 different dimensions. And then I happened to think Carl Sagan said there were, what, over 200 when the world was formed or so. So I guess there's a lot out there we don't know about, right?
More dimensions. Yeah, there's a technique. There's a technique in mathematics called multi-dimensional scaling, and they work in many dimensions. They solve problems with it.
Okay, who's next? We gotta have a next. You got another? You want to get up here? No? Are we running out of people? Oh, I can't believe this. I'm the last man standing. I don't have anything to say. Well, I guess I'm the last one to talk, so I think our speaker did a great job tonight. I got to commend him for that. It stretches the mind, what we have to do, and that's basically what we have. That's what we have to do. Anyway, Our speaker gets to comment on the comment and close this meeting, so you have the last word.
Thank you. Well, I'm going to respond to something, but we did talk about religion. I see three functions of religion that they can serve. One is a personal code of conduct. I was taught one as a young man. I felt it was beneficial to me. The second is as an underlying ordering ideology for society. And we were blessed with a unique, monumental change in terms of the construction of underlying documents for the nation when they began to say inalienable, creator-given inalienable rights. And that's where we came up with our Bill of Human Rights. That was a step forward. The third item, and I consider this, and that is for whatever religion you're in, are you a believer in it or not in terms of an afterlife? So I've taken a position here on, I'll take a position, tell you what position I've taken. I'm the only survivor of my initial family. If I was going to go through the rest of my life thinking I'd never see those loved ones again, I'd be a little depressed. So I've got the choice to either be a pessimist or an optimist. And so with the possibility of an afterlife, I've got hope for eternal life, hope for universal eternal justice, hope for reuniting with departed loved ones, and in the religion I'm a part of, Christianity, I've got hope for an advocate with the all-powerful, potentially intimidating deity, and finally hope for a deity that be loving and forgiving and protective. You know, so that's a positive view. Now there have been a lot of bad things done in religion. This History Channel today, you know, as I understand it, I don't know what percentage of Germany was Christian, but that was terrible. What they did was absolutely horrible. There have been horrible things in terms of malpractice of the principles that Christ taught. But I have two simple questions. Well, I've really got 7 in all. I'll just share 2 of them. One is this. What country or countries would you want to live in whose founders and populations were not predominantly Christian? And the second question is, what countries or countries in the world have constitutions with bills of human rights whose founders and populations are not predominantly Christian? And then what countries in the world whose founders and populations are not Christians where you can practice your religion openly and on property? So, you know, I've made my decisions based upon what's functional for me as an individual code of conduct, what's I think has been instrumental in improved underlying documents for a nation, and in terms of hope for the future. And so, to be honest with you, it's just a matter of my being optimist or pessimist. And you know what? Doggone it, maybe I just couldn't live with the thought of not being able to see again my mom, dad, and my sis. I loved them, you know.
They kick us out of here at 9 o'clock, just so you know. And we generally gravitate down to Starbucks, and our speaker is more than welcome to come down there. So we gravitate down to Starbucks, and you can talk to our speaker down there. We usually go there after this, so you're more than welcome. And because they kick us out of here by 9, we have to be out of here before 9. So anyway, that's it till next week. So thank you.
This is William, your videographer from Two Hats Publishing. I hope you enjoyed this video. If you like it, please leave comments below, or like us or follow us and get notices of all our videos. We love it even when you call. So when visiting the Barbec's restaurant, tell them you want your reservation to the next College of Complex class.